Hello. So I will be discussing on how to write and balance a chemical equation. Okay, so let's try first to write this sentence into a chemical equation. So um, for this, it is important for you to know how to convert chemical names into chemical formula. So we'll do this step by step. So nitrogen gas. So the chemical formula for nitrogen gas is N2 reacts to hydrogen gas. So hydrogen gas is H2. Okay? So to produce ammonia. Ammonia has a chemical formula of NH3. Okay, so with this, we would like to convert this into a chemical equation. So this is N2 reacts to hydrogen gas, meaning to say nitrogen gas and hydrogen gas are both both reactants. So it means they should appear in the same side of the chemical equation. So this will be the reactant side. So this will be N2 separated by a plus sign, which denotes the reacts to praise. Okay, so N2 plus H2 to produce. So to produce, it means that the reaction will proceed to the creation of new products. Okay, so to produce will be denoted by this arrow, ammonia, so NH3. So this will be our chemical equation. So on balancing, it is important to write first all the elements present and count the number of atoms of that specific element in the chemical equation. So we have nitrogen and hydrogen on the reactant side, and same with the product side. So there are 2. So 2 nitrogen, so denoted by the subscript 2. Plus hydrogen, there are 2 hydrogen. Okay. So another one is on the product side, nitrogen has 1 nitrogen, and hydrogen, there are 3 hydrogen. Okay. So on balancing, we would like to have the each of those element to have the same number or same values. So if you have 2 nitrogen on the reactant side, we should have 2 nitrogen on the product side. So this is on correspondence of law of conservation of mass. So to balance this one, so I would like to place 2 as the coefficient on the ammonia. So it means that if you place a coefficient on 2 on ammonia, I will be multiplying 2 to all the elements in the ammonia. So this will be 1 times 2 will be 2. 3 times 2 will be 6. So we have now the balanced nitrogen. We have 2 nitrogen on each side. However, hydrogen is not balanced. So we have 2 on the reactant side and 6 on the product side. So in order to balance this one, I will be placing 3 as the coefficient on H2, and this will multiply 3 to all the hydrogen atoms. So we have 2 times 3 will be equal to 6. So hence this will be our balanced chemical equation. Okay, so this will be balanced chemical equation. Okay, so let's have other examples. Okay, so water produces hydrogen gas and oxygen gas when subjected to electrolysis. So water is H2O. Produces, it means that this is the separation. This is the word that denotes the separation of the products and the reactants. So produces will be denoted by arrow. Hydrogen gas. So hydrogen gas is H2. and oxygen gas. So this will be plus and O2. Okay? To balance this one, we count all the atoms on each sides. So we have hydrogen and oxygen. So there are 2 hydrogen and 1 oxygen on the reactant side. There are 2 hydrogen on the product side and 2 on the product side, oxygen on the product side. Okay? So to balance this one, I would like to place 2 on H2O. So this will be this will multiply 2 to hydrogen and oxygen. So this will be 2 times 2 will be 4. 1 times 2 will be 2. So we have now balanced oxygen atoms, but we don't have the balanced hydrogen atoms. So to balance all the element hydrogen, I would like to place 2 on the hydrogen gas. So this will be multiplied by 2. This will be 4. Hence, this is our balanced chemical equation. Okay? So next one, copper metal reacts with oxygen gas in order to produce copper 2 oxide. So this is copper metal. So this is Cu reacts with oxygen gas, meaning they are both reactants. So plus oxygen gas, which is O2, to produce copper 2 oxide. So again, you need to know how to represent chemical names into chemical formula. Okay? Copper 2 oxide is CuO. Okay, so to balance this one, I should count all the copper and oxygen. Copper and oxygen, the reactant side is 1 and 2. Copper on the product side is 1 and 1. To balance this one, I think I should place 2 on the copper oxide. So this will result to the multiplying 1 of oxygen to 2. So this will be 2. And for copper, of course, you place coefficient on the copper oxide. So you should also multiply 2 on the copper. So this will be 2. So we got the oxygen to be balanced, but copper is not balanced. So in order to balance copper, I should place 2 on the copper side, copper metal. So multiplying this one will be 2. Hence, we will have the copper and oxygen as balance. So this is now our balanced chemical equation. Okay, let's move on for number 3. Number 3, ferric hydroxide. Ferric hydroxide is FeOH3. Decompose. So this is also another term to produce. However, decompose are usually used when we have one reactant and it results to a multiple number of products. So this will be ferric hydroxide. Decompose, so I will place an arrow here to form ferric oxide, which is Fe2O3, and water. So this will be H2O. So we have ferric, so iron as 1, oxygen as 3, no? And hydrogen also have 3. On the product side, we have 2 iron, oxygen has 3 plus and 1 here. So we have 3 here and 1 oxygen here. So this will be 3 plus 1 is equal to 4. And hydrogen, we have 2. Okay, so to balance this one, I should think of a number to balance this. So probably I need to balance first iron. So to balance iron, I should place 2 on the ferric hydroxide. 2 on ferric hydroxide. So this will result to the 2 atoms of iron. Oxygen will be multiplied by 2, will be 6, and hydrogen will also be multiplied by 2, which will be 6. So we have 2 iron balanced, but oxygen and hydrogen are both unbalanced. So to balance this, I think I should balance first hydrogen. So I will be placing 3 here. So this will result to the multiplication of 3 and 2 of the hydrogen. So this will be 6. But of course, since you place 3 on the hydrogen, water, you multiply 3 on the hydrogen, you also need to multiply 3 on the oxygen, on the 1 atom of oxygen. Don't include the 3 on the oxygen on the ferric oxide. So only the oxygen on the water. So 1 times 3, okay? So this will be 3 plus 1 times 3 will be equal to 6. Okay? So we have 2 iron, oxygen, both are 6, and hydrogen, both also 6. So we have the balanced chemical equation. Okay? Sodium peroxide reacts with water to form sodium hydroxide and oxygen gas. So, rewrite. So, sodium peroxide is Na2O2. Reacts, so plus water H2O to form sodium hydroxide and oxygen gas. Okay, so I should count all the atoms. We have sodium to be 2, oxygen to be 2 plus 1, which is 3. Hydrogen 2. So other side, sodium we have 1, oxygen we have 1 plus 2, which is 3. So hydrogen we have 1. Okay, so we don't have balanced sodium and hydrogen. So to balance this, I should place 2 on the sodium. So this will be 1 times 2, which will be 2. However, since I placed 2 on the sodium hydroxide, I should also multiply 2 on oxygen. On the oxygen with 1 atom, don't include the oxygen of 2. So I place 2 here. So 1 times 2 plus 2 will be equal to 4. Hydrogen, I should place 2 on hydrogen, which will be 2. So it turns out I have balanced sodium, which is 2. I have balanced oxygen, which is, balanced hydrogen, which is both 2. Now to balance oxygen, I should have 3. However, if I have 2 here, plus 2 is equal to 4. So maybe I could manipulate this oxygen gas wherein I could reduce the number of oxygen here to 1. From 2, I should replace it to 1. So in order to transform 2 to 1, the number that I should multiply to 2 will be 1/2. So with this, if I have 1/2 on the side of oxygen gas, so I should multiply 1/2 to 2. So we have 2 oxygen, 2 here, and multiply by 1/2. So this will be 2 plus 2 times 1/2 is equal to 2 plus 1, which will be equal to 3. Hence, we have now balanced chemical equation. 2 sodium, 3 oxygens, and 2 hydrogen. However, it is not appropriate to present a chemical equation wherein we have coefficient in a fraction form. So to resolve this, you should think of a number that when you multiply at both sides of your chemical equation will result to the formation of coefficient to be in whole numbers. So I think the number I should multiply will be 2. So when I multiply 2 here, so this will be 2Na2O2 plus 2H2O results to 2. This should be 4 NaOH plus 1/2 times 2 is 1O2. Okay? So I should count all the number of sodium. So to check, we have sodium 4 on the reactant side. Sodium on the product side also have 4. Oxygen, we have 2 times 2 is 4, plus 2 times 1 is equal to 2, which will be equal to 6. On oxygen on the right side, we have 4 times 1 will be 4, plus O2 plus will be 2 is equal to 6. And hydrogen, we have 2 times 2, which is 4, and the product side we have hydrogen, which is equal to 4. So we have now balanced chemical equation. So this is our balanced chemical equation. Okay, and last example, let's have a last example. So phosphoric acid is H3PO4 reacts with plus HCl to form phosphorus pentachloride, which is PCl5 plus H2O. Okay, so this will be hydrogen. We have 3 plus 1, which is 4. Phosphorus, we have 1. Oxygen, we have 4. And Cl, we have 1. On the product side, we have hydrogen 2, phosphorus 1, Cl 5, and oxygen, I should place okay, oxygen has 1 and chlorine has 5. Okay, so to balance this, I think I should place 5 on HCl's, because this will be much easier when I first approach the odd numbers. Okay, so 5 HCl, so I will multiply 5 on the 1 atom hydrogen, so I will place 5 here. So we will be having 8 hydrogens. And on chlorine, I multiply 5 here, so this will be 5. So we have now balanced chlorine. However, the other elements are still not balanced except for phosphorus. So we have phosphorus and chlorine to be balanced. So to balance this one, I think I should place 4 on H2O. So for this, with this, I will be having oxygen to be 4. So we have balanced oxygen, and since I place coefficient 4 on H2O, so this will also include hydrogen. So 2 times 4 is equal to 8. Now, I have balanced chemical equation. So we have 8 hydrogens, phosphorus has 1, oxygen has 4, and chlorine has 5. So this is our balanced chemical equation.